Hi, it's Graeme Cox here, and I'm going to give you a quick demonstration on how to convert a Land XML file to a Trimble construction control file. Firstly, you've got to get this file, this program called Trimble File Flipper. I'm using version 1.4. Whatever that is. And when you load it up, you should get a screen like this. You'll browse to the Land XML file. You'll open it. You'll click continue. Then if it reads it incorrectly, you'll get an option for surfaces. You can only export one surface into construction systems generally, so you would select this surface, the proposed surface, and click continue. You select the system that you're going to export to, and it looks like the older systems are called the GCS900s, and then the new ones called the Trimble Earthworks. So select the one you're doing, saying you're using GPS, yes. If the data's collected in a large coordinate system, like a global coordinate system type thing, you'll end up with, you'll have large numbers. The eastings and northings will generally be in the hundreds of thousands to millions. So you can easily check that in your file, just have a look. But you should know what coordinate system you're using. So say in this case we were using some data that was collected in Australia, and it was using this GDA 2020. Your surveyor should be able to tell you which coordinate system they were using. This is like a UTM coordinate system for Australia. It covers the whole Australia, but it has zones. So you'll click there. Before I go there, let me just check. If you go to the bottom on country, continue. Yeah, that's the UTM's the most generic system that most people are using around the world. Even the GDA 2021 that I just showed you is basically a version of this UTM coordinate system. So you can select UTM if you don't really know generally, and then you've got to find the zone. So there's 60 zones spread around the Earth, north and south. That it depends on the latitude strip. It's a strip around the Earth. So in where we live, it's South 56, Zone 56 South. So, but you should be able to find that. Just do you can search Google for UTM zones and you can get some images. Looks like there's even an interactive map here by someone. And then these are the different zones. So this is, if we zoom out, we're in zone 56 South, Southern Hemisphere, but you can see them all over the world. And that's the default system we use in AgEarth and OptiSurface Designer. If you're pulling in latitude, longitude data. Yeah, so in AgEarth, if you go to Project Properties, you will get down here the coordinate system. So that's the UTM. And it's basically, yes, it's zone 50H there, so that's 50 south effectively. Zone 50 south. And that'll automatically be calculated. If you import data with latitude, longitude, and elevation in, it'll automatically calculate which zone the first point in the file is, and then it'll set that for the project. So yeah, let's run with that 50. So I'm going to, in this case, it's a 50 south. I'm going to click continue. We'll be using a geoid. Now, geoids are only really significant over large distances, like many kilometers. It's basically how the water flows over the earth rather than a smooth ellipsoid. It's water, different gravity, potential across the earth's surface makes water flow slightly differently, but we're talking about, you know, centimeters over tens of kilometers generally. So it's generally not significant. And there is a bug in here. I tried to download well, that's a global geoid. Even that one's not downloading. There's an error. So I couldn't get them to download, but so basically, yeah, just don't use a geoid. It won't be significant unless you've got a site that's maybe, you know, 10 kilometers long and you've got significant, yeah, it's in most places in the world it's not significant. So I'd, yeah, basically just ignore that. And then, so now it's saying, okay, what do you want to call this file? So that's exporting to this. You can set this. This will be the file name. Oh no, that's what we're importing. You can change this to whatever you want. Click save. It'll ask you where you want to save this. I'm just going to save it to downloads folder, and it'll create another machine. It'll put it in here if this doesn't exist. I'm just going to go downloads. You can see it's going to put it inside this machine control data folder, and then it's going to create this V. I think I've already got a V1 in there, so it should be. You might have to update that to a V2 if you've already got one in there. I don't know. Let's just try that if it does. So can we go to, yeah. Would you like to have another design from the original file? Yeah, so it has created it there, but it's probably overwritten their version one that I had in there. It does give you an option to export another surface. Now, if you want to do a check, you can export this existing surface. And that will allow you to, no, yeah, that will allow you to, so I might want to put here existing. Right, and then you can load that file up and check the existing topography matches up by driving around the field on auto. The blade should be skimming the ground because you're just covering. Convert export is. Well, we've got V2 here. Done. So if we look in that machine control file, you navigate down to all, you'll see it's got some folders here. These are the ones I've just done now. And V1, that must be proposed, and V2 must be existing, even though I typed existing in, but I think you can change these folder names as well if you want to clarify it. But if we go and look in there, there's an SVD file, which is a surface file, Trimble format for a surface, like a triangulated surface. That's there. And then there's this site calibration file, which is basically tells the tells the machine control system what coordinate system to use, which is that zone 50 thing. Yeah, see that 50 south, maybe here we go, 50 south, WGS84. So now you can actually do let's just do another one. And let's say we're going to be using Yes, let's local calibration. Now you can use a local calibration file, which is basically you can have, I'm not sure about these exact formats, but these files, one of these files, I think you can have a number of points with the latitude, longitude, and elevation for a point, and the eastings, northing, and elevation for that same point. You can have you have to have at least 3, probably maybe even more, 4 or 5 points, and it'll use those points to produce a calibration, because it has to basically convert a GPS latitude and longitude into your local eastings and northings that your design is in, and so it needs a way to do that calculation, and this calibration file is effectively telling the machine control system how to do that latitude and longitude to easting, northings, and elevation. But that's a lot more complicated. If you've got it using a standard coordinate system, it's straightforward. Okay. Hope that's useful. Let us know if you have any questions.